We will start in a few more minutes. More people are joining in, so we'll wait till 5-10 minutes while people are joining. Hello everyone. Hope you're able to hear me. Um, if you're not able to hear me clearly, you can post in the chat. I will have a look. Um, so welcome all to the third week of the session on Python for data science. Uh, I'm your teaching assistant for this course. So some of you might be new for this week, who may not have previously joined last few weeks. So, to introduce myself, so I'm Pratik Chanda. I'm a teaching assistant for the NPTEL course on Python for data science. And so this is a third week now. So, brief intro about me. I am a fifth year PhD student at the Department of Computer Science and Engineering at IIT Bombay. My research work is around machine learning and AI, particularly for large language models. I also have previously done my internships at Google DeepMind and Microsoft Research. So across all these projects and research works, like I have deeply benefited from Python and the nuances of the programming language. So I hope you can also get a hands-on overview of the Python language in itself during the course of this lecture series. And we'll start in a few more minutes. I think since more people are joining in, so we will start in some more time. I would be sharing my screen. So if you are able to see my screen in some time, please confirm once. Um, so let me just try sharing my screen. Um, Okay, I hope you're able to see my screen. If you're able to see my screen, you can share in the chat if you're able to see, or if you're not able to see, you can also share in the chat. So going ahead, I think people have joined. I think most of them. But still, will still continue. I think once people are like people can join in as they want. So this is the third week of the course Python for Data Science by NPTEL. I will first give a brief outline of today's session, like what we will be discussing, and then head on to a brief recap from last week, the discussions from last time. So let me just reshare my screen once in the meantime. So a brief recap from last week would be there, and then thorough discussion on today's session about the contents for today's session. So last 2 weeks we had mostly discussed on two things. One was so week one was mostly around like introduction to Python and like different coding platforms for Python, like for example like we used looked at Spider and VS Code, Visual Studio Code as one of them. So uh, all this sort of platforms are kind of similar to each other, and we had looked at different such notions of them. So this was our first week setting that we had discussed. The second week, which was last week, we had looked at sequence data types like strings, lists, arrays, and so on. And we had covered the different aspects of these data types, like how each data type shared certain properties, and some properties are very unique to them. For example, mutability of these data structures. So we also looked at how to create an instance of these data structures, like in for example, list, or in case of dictionary and all. So all this we had discussed from last time. So what we would now going forward, we also looked at how to insert new elements to this kind of sequential data types like list, array, and all, and also show like went through different examples of this data structures. So we would like to first cover a bit portion from last week, which was on NumPy ND array, and then head off to pandas data frame. And today we'll be looking at some dataset plots and like different styles of plotting visualization using Python, particularly using matplotlib and seaborn libraries, which are like specific Python libraries. So we'll look at those, and then we'll look at a different control structure for Toyota Corolla dataset, like if else, for loop with if break, while loop, and so on. And that's would be most of it for today's session. We'll also look at some, because would be looking at pandas data frame. We would be also looking at how to read files, like how to do exploratory data analysis on top of it, different pre-processing setups, and all those things we will look at also today. So with that, I think we will start now. I think most people have also joined. I'll just make sure that I will just first make sure that everyone is able to hear me clearly and also is able to see my screen. If you are not able to, if you have like any problems with my like hearing my voice or any hearing the seeing the screen or anything, please feel free to share in the chat. And just okay. So now I think we'll move ahead with the setup from last time. So I think this was slides from last time. I had actually shared these slides also in the chat, and you can also find on YouTube the lectures from last week. If you're first time joining for this week, you can find both the lectures on YouTube from last week. So going ahead, I think we had stopped at NumPy settings, but we didn't actually fully finish it from last week. So we'll look at that today, and then head on to the data frame setting. So we stopped at this particular slide. I think I will mostly cover a high level overview of this thing because this slide is a bit detailed. But since in data frame also we would have some aspects of NumPy associated with it, so we'll look at it, the remaining detailed portion of it in that slide itself. So we looked at last week about how to create a multi-dimensional array in Python. So this involved in terms of like if you have a 2D array, let's say you have to create where you have a 3x2 or a 2x3 kind of matrix. So in those cases, how do you create such a data structure using NumPy? So a very simple instantiation of this is via this np.array thing, within which you can provide the corresponding entries of the matrix, and it would create the corresponding entries like this. We stopped at discussing about different functionalities of np.array, like ndim, shape, size, and dtype. And these are like various like utility functions kind of that you can think of. And yeah, so we mostly had looked at the basic anatomy of this NumPy array. So today we'll look at the type conversions and aspects of NumPy ND array, how you can easily do those things in this setting. So a NumPy ND array normally has one D type. So D type basically means like whether your entries in the matrix is of type integers or float or not. So if it's integer, then you typically call it as int 64, or float is like float 64, or you can also have 32 conventions also. So so here, for example, I have shown here like A is a array of integers, and B is also is having items of mixed kind data types. One is of integer and one is of float. And now what I want to do is that I want to create a second matrix C, which is the duplicate of A itself, but has type np.float64. So now if I print C, I would get 1 point something, 2 point something, 3 point something. So it's basically it's converting each of the integers into floating numbers. So this is like how you can convert from one aspect of this data type to another data type. So NumPy finds a compatible common D type during your creation process, and as type creates a converted array. You can also do integer division or mixed values to promote floating points while creating the array aspects. So there is also other things like if you want to change the shape of the array, then how do you change that? So for example, you already created a shape of array of, let's say, 2 cross 3, let's say. How do you change it to 3 cross 2, let's say? So something like that, you can reshape those things. So for example, here we have an array. What we are doing is that np.arrange 1 to 7. So that what basically that does is it gives you all the numbers from 1 to 6, 1 to 7. 7 is not included, so it gives you 1, 2, 3, 4, or 5, 6. And now what you are doing is that you are doing m equal to a dot reshape 2 comma 3. So this entire list of numbers 1 to 6 is now reshaped into a 2 cross 3 matrix. So 1, 2, 3 goes in the first row, and then 4, 5, 6 in the second row. You can also do it as you can do a reshape of it and get the columns out of it. So you get 2, 3, 6, 1 out of it, and so on like this. So you can also do transpose operations and all those like matrix transpose operations, like which is like just m dot t would be like you would transpose that matrix. So all the rows would become the columns, and all the columns would become the rows, like that. So, and the other thing is about indexing and slicing, which we also had discussed last time on around lists and arrays. So similar to that, we also have this property in case of NumPy array. Given this array of 5 numbers, you can give index numbers here. Like let's say these are all again zero indexed. So it starts at 0 and then goes on like that. So you can provide the index number and also give the how many numbers you want to retrieve. So likewise, you can print things here. So it uses NumPy uses the same kind of start inclusive, which is the zero indexing, and stop exclusive slice rule as normal is seen in Python sequences like list, dictionary, arrays, and all. Again, you can do this thing in two-dimensional settings also, where if so in two dimensions, instead of having only a single indexing, you now have two indexing because you have a row indexing and a column indexing. So given this array, you can retrieve specific elements in the array via giving the row ID and the column ID. If you just give a single number here, it would give you the corresponding row. And if you want to extract out the column, you would give something like colon, comma, the column ID. The colon, comma basically means that I am not searching through the rows. I'm just so give me the is like a wildcard search for the rows, and column one, the column ID basically gives me the entire column ID. So likewise, you can do different operations in case of NumPy array, like slicing, indexing across rows and for multiple such for a large dimension array. So this is just for two-dimension array, but you can think of it as also extending to 3D, 4D kind of arrays also, like tensors kind of. settings. So the other important thing is that basic NumPy slices are usually like called views. What I'm doing here is this is just follows that I have an array of these numbers. So now I am creating a new sub array of that called view, which gives me numbers from index 1 to 2, because the last 3 is not included. So it would give me 20, 30. And what I'm doing now is that I'm setting view 0 is at equal to 999. So if you print view only, so it would give you 99930, because you are replacing the first element, which was 20, with 999. But if you print A now, the original 20 gets replaced by 999. So this is the basic difference with the list slicing. So in list slicing, what you have is that you don't if you modify the subarray using a separate variable, the original number list doesn't get changed. But here it gets changed, and so this is basic difference is that unlike a list slice, a basic NDRA slice is commonly shares the same original data buffer. So whatever changes you are making in the subarray, it gets reflected in the original array also. So to mitigate that, so for example, if I don't want to change the original setting, so what I can do is that I can use something called copy. So copy creates a independent data buffer, and if there I can modify things, and in that setting, it doesn't share the memory across the original and the copy. So np.shared memory is a function utility that tells me whether the original copy or original matrix and the copy of that matrix share the same memory or not. And typically, if you use dot copy thing, it creates a new memory allocation for it. So if you change the assignment at any point for the copy array, it won't alter the original array inputs. So now the third thing is about called Boolean masking. So again, this is very similar to list settings also, which we had used. So I'm going through this a bit in a high level setting. So given this array, you can create conditions for it. Like let's say I want to only retrieve elements in the array that are greater than some threshold. So I can write it like uh, scores, and then within the index, I can add the conditions for which my items in the list are greater than equal to some threshold or less than equal to some threshold, and I can retrieve those elements only. So these are like very simple aspects which are very similar to lists and other settings. You can also do some kind of integer positions based indexing settings also, like so these are like kind of like a bit advanced kind of um, functional utilities for NumPy. So I won't be going through all of them right now, because you can also go through the documentation of for NumPy to understand these things. Although not all of them are required in day-to-day kind of your Python coding. There is also vectorized arithmetic and comparisons that like similar to list comprehension that we saw, which uses something like vectorization aspects. You can also use something similar to here also. Like instead of doing, let's say I want to multiply all the numbers in the array by 2, let's say. Instead of doing like a for loop for the entire thing, I can just do is the array start 2, let's say. So it would just do a vectorization operation, and it's much more less costly than doing it in a for loop fashion. Uh, if you have a larger, let's say, um, uh, matrix and all, you can also easily do a matrix multiplication using at the rate symbol. So because matrix is a not a one-dimensional scalar, it has some shape to it. So you can't use the simple star. You would have to use this operator at the rate to multiply two matrices. And of course, you have to check that the shapes are kind of matching, like the last index of the shape of the left matrix should match uh, the left index of the right matrix. Otherwise, it would give you uh, some error that the matrix shapes are not matching for multiplying. So all these things are there, which are typical in linear algebra settings. So NumPy also has a function utility called linear algebra, like LINALG, which gives you different linear algebra kind of functionalities. So I would highly suggest, like, whoever are interested to look through the documentations and work through it. So this is much more useful, I think, when you are looking at machine learning applications where you have to look into these things. So I think there are other aspects like aggregation operators, like sum, mean, maximum, standard deviation, variation, all those things. So given an array, you can calculate the maximum, minimum, argmax of it, standard deviation, and all these things. All these operations are provided in these, right? So that's all, I think, mostly about the thing. So I think I will not be going through all of the settings this time. So I will so again, like, another important thing is about numerical data where you have missing values. There is this thing called NaN. So NaN is basically when you, let's say, you have a missing value in the data set, or or even in case of neural network training, let's say, your certain weights or parameters in the network goes beyond high threshold, let's say. So you can consider NaN as, like, typically people use NaN as a as a value for that. So if your data set doesn't have certain values or it contains missing values, you can replace with np.man. So all these things are there, and there are multiple. So for example, if you have to calculate the average or the minimum of an array where these missing values exist, so how can you calculate those? Because since there is a missing value, you can't actually just simply apply an average across all the items in the array. So NumPy provides you this functionalities like NaN, mean, NaN sum, and all those things that gives you this different like different functionalities even when your array contains NaN values. So I think those are kind of the settings. I think I can now move on to today's topic, which is more on pandas data frame and all. And if there are any questions till now, we can take in any questions for 1 or 2 minutes, and then I would head on to the pandas framework. So, okay, I think there are no questions. So then I think we can move ahead with the today's lecture course on pandas. So pandas, I think, is a popular library used in machine learning and data science aspects. So it provides multiple functionalities. One is that, let's say, you have a large data set where you have multiple features in the data set. Let's say you have uh, a typical example can be like, let's say, you want to buy a house, let's say, and for a house, there are multiple features associated with it, like the location of the house, how big is the house, or the sort of the price of the house, and sort of the amenities and all those things. So all these things can be considered as features for that house, and you can typically think of this all this information stored as a tabular format, in a table format, where given this house with these features, this is the corresponding price associated with it. So a house with this location, with this amenities, this number of rooms and all those things has this price. So you typically can have this information represented in a table format, and you can have large number of such data points, like multiple houses and with corresponding features for them and all. And how do you actually sort of visualize that? So how do you visualize this big table in a interpretable manner where you can understand like which are the important factors for a bigger price for a house, or like which factors matter more when buying a house and all these things. So this is a typical example, and this can be extrapolated to even complex domains where you have finance or you have bank statements, let's say, all those things where there are multiple such information, which some information might be sensitive information, which you have to, let's say, mask, or let's say can't have that stored in a tabular format in plain text. And there might be some cases where you have missing values also, which we were discussing a few minutes back, like like some of the data points you don't have, let's say your Sensex data, let's say, or let's say this voting data for parliament and normal election voting parameters and all, where you don't have certain data points in the table, let's say. How do you visualize and how do you pre-process those things? All those things actually can be done using pandas data frame, and also it borrows some concepts from NumPy also. So some of the functionalities they have common kind of functional utilities also. So we look at those things today, and particularly we would also look at a particular data set called Toyota Corolla, which is a part of the lecture series syllabus for this week. So we look into those things today. So the opening question is this: that there is this particular data set. So given this data set, particular Toyota Corolla data set has this, that given age, mileage, fuel type, power and weight, how does it relate to price of a used Corolla? So basically, like a car, you can think of where you have to decide based on the fuel type and mileage aspects of the car, and based on that, how you can predict the price or of that corresponding car. So we'll look at that in the upcoming slides. So what you'd be able to get out of it at the end of this session is this: that how to handle this kind of tabular formatted data like CSV data or Excel files, how you can inspect or select or sort or all those things in these data frames. The second thing is about to identify patterns in this data, like for example, how do you create based on the visualization aspects of about the data itself, how can you gather some kind of patterns or insights from these data sets? The third thing is about, of course, automating decisions, based on the patterns that you observe in the data set, like what sort of decision can you take? For example, let's say I based on the pattern of this Toyota data set, I want to sell cars which has, let's say, mileage greater than some threshold, let's say, or has fuel type this thing. So I want to sell more of them in my application. So all this decision automation can be done via different aspects of if-else loops, while and functions uh, in Python. So we'll look at the dataset which involves total 1436 car information. So there are 1436 rows or entries in the table. There are 10 columns in this, and 2004 used car listings in Netherlands. The target column is the price, and the features, which are the corresponding feature that I was mentioning about the data set, are like mnemonic predictors like age of the car, kilometer, HP, CC, doors, weights, and all. And there is also a category of flags, which are like non-numerical data, which are like fuel type, the color of the car, automatic or this thing, manual. So all these things are there. So if you consider this as a data dictionary, let's say, because we had already looked at a dictionary as a data type, so this can prevent like wrong interpretations because certain columns have different meanings. So some can be like numeric kind of features, like where you have a number feature associated with it. Some kind can be a binary feature where you have where you have like whether it's a true false kind of setting. For example, in this particular example, whether it's automatic or not or manual, that's a binary indicator, like whether it's automatic or not. Whether my fuel type is petrol, diesel, or CNG, that's a categorical type. So there are only three options there. So the car can be either of the three. And similarly for other things like age of the car, kilometer, and all those things would be numeric values. So you can't actually infer all the units from the column name itself. So you need metadata about the data also. So before plotting and doing any visualization aspects, you also need to be extra careful about these units also. So the first thing would be to look at how to read the file. Given this data set, how do you read it? And now how you can introduce pandas data frame to pre-process your data. So the first task is not about analysis of the data, it's just verifying whether the data has arrived correctly and you can pre-process it correctly or not. So we start with the reproducible setup. So for people who have a Visual Studio Code or any sort of ID platform already available with you, I would highly suggest that you can also try it out along the way. It would give you some kind of like hands-on experience while you work through the entire setting. So we use pandas data frame as a library. So we first import all the libraries at the top. So we do import pandas as PD and we also import numpy as NP. So these are like allies as we had discussed last few weeks back, that you can import a library and kind of give a alias name to it like PD or NP, because this is just useful for like just just for convention wise as well as for typing speed and all. Like you don't have to call all the time pandas dot something. You can just call PD dot something or NP dot something. So there is also one other library called matplotlib, which is a very popular library in Python for plotting functions and visualization. There is also this another library called Cbon, which gives you a very complementary kind of style of plotting to Matplotlib. So we'll look at both of them in this setting. So what we are doing here is that we are setting a theme for Cbon with some white grid background, and we are also setting the pandas data frame with like kind of the display for it with maximum columns is set to 20. So now this functionality is as follows. Like we call this pd.read CSV. So given the CSV file, which CSV file is basically comma separated files that you have. So each row would have all the feature values and all the numeric features, the price and all those things separated by commas. So you just read the CSV. So it provides you pd.read CSV, and you are assigning this variable Toyota, and yeah, it creates a data frame out of it. So it gives you a table kind of structure from the CSV file. So typically you have to just pass the path of the file, like wherever the local file path is. You also can give some separator, like let's say if the features are separated by commas, the default is actually using comma, but you can also, if your file has semicolon or let's say other kind of patterns, you can also use that as a separator. Encodings and all those things you can specify like UTF-8 and all. And if you have missing values, let's say NA and all, you can replace that with NA or question mark or any other choice. So that during the visualization process or the pre-processing process, you can handle this kind of things. So now these are like uh, different file patterns where you can read from using patterns. So for CSV or TSV files, you can use pt.read CSV. For Excel files, you can use read Excel. JSON files also you can use as read JSON, and you can also read a text table file using read table file. So any .txt file which has a table in it, you can read it like that. So it provides a wide variety of API calls or functionalities across different file formats. So it's very useful. Even if you don't have a CSV file, you can just use any other file formats and get the same benefit out of it. So yeah, any questions up till this point? If you have, you can ask in the chat. I will try to answer them while we move ahead. Yeah. So now we'll move ahead in the setup. So we first look at the one of the other functionalities called head function. So now we have read the Toyota as a data frame. Toyota equal to pandas dot data frame. This thing. So you can do Toyota.head, which gives you the first 5 rows in the data frame. So on the right hand side, I'm showing you the output, which is Toyota.head gives you the first 5 entries with in this table format with the columns as the features, the target price, and the features as follows. You can also do Toyota.tail3. So Toyota.tail basically means that from the end of the data frame, you should sample out the rows. And if you provide a number within the brackets like 3 or 4, it gives you the corresponding number of rows. So Toyota.tail3 basically means the last 3 rows of the data frame. So similarly, Toyota.sample 3 comma random stretch 7 basically gives you any 3 rows in the data frame itself. So the first thing is to just do is to once you create this data frame, you just type dot head. What you should do is that you should look at the whether the headers are actually correct or not based on the data set, whether you are actually reading the data frame correctly. There might be some headers that are kind of missing, let's say, in the data frame. Then you have to go back and see whether there were some issues with the separator or not. You have to provide that thing and then reprocess that once again and then see. So the second thing is to look at are the numeric values split into any numeric columns or not, and the categories that you have, let's say categorical features, those are kind of looking correct or not in the setting. So the head actually is, dot head actually checks for the structure, and dot sample checks for any risk of judging the file just from the first row. So that might be you might get correct rows in the first 5 or 10 rows, let's say. But if you want to actually see overall, let's say you might not know, like let's say the 100th row in the data set might have the issue and you don't know. So if you do sample thing, it gives you random samples. So you can just randomly check like whether it's the entire thing is correct or not. And so you can think of the data frame as a two-dimensional table where you have on the columns you have the features and the target, and on the rows you have the index labels of the corresponding rows in the data set. So every cell is basically a row column intersection that you have here, and your corresponding columns are actually have your data and numpy data d types and names. And so there are kind of the initial checks that we already saw is the follow. Now we look at the following other checks that you should also look at. Like one is the shape of the data frame. Shape basically means that what is the total number of rows in the data frame plus the number of columns. So if you have, let's say, 1436 data set size, that means total entries in the table is 1436. So should be the number of rows, and columns. You here in this data set you have 10 columns. you have 10 as the corresponding entry level. You can also do Toyota.columns, which gives you the column names actually, the numeric columns, the category columns, and all these things. It gives you the names of the columns. You can also do D types. D types actually gives you the corresponding columns and these corresponding D types according to it. And also, like, info is also another thing that gives you types and the non-null columns, or that means the ones where you have no missing values. So those gets counted and gets shown. So so now the goal is to actually so I now have this table created. What I want to retrieve is a particular column, let's say, from the table. So I now want to have a particular column retrieved from the table. So what I can do is, like, I can do something like dot price, price within quotes. Price is the name of the column, let's say. So it would give me a single column of from the data frame. This is typically called pandas series actually. So this data type for price is basically pd.series. So single brackets on the right. So this is like my bracket rule that we have here. So single brackets basically gives you my series. And if I have list inside the brackets, then it gives me a data frame. So now if I want to create, retrieve like several columns, let's say. So I want to, let's say, get the sub data frame of the original data frame. So there, what I can do is that I can do Toyota, and then within that, I pass on a list of sub columns like age, KM, and HP. So it gives me a 1436 cross 3 data frame, because all the entries are entries, or the rows are retrieved only corresponding to the three columns from the data frame. And so these are like different ways to retrieve information from the data frame itself. You can also use something called .loc that gives you corresponding location wise like, if you also want to have corresponding rows only to retrieve, not the entire list of rows, then you can specify that in the settings before the comma itself. So dot colon, as we saw in NumPy and other list settings, dot basically means the colon basically means that all the entries should be retrieved corresponding to the columns price, age, and KM. But if you can, you can also indicate the row IDs also, and it would just give you those rows only. So, for example, Toyota.loc0 gives me the first row in the data frame. Row, if I just want rows 0 to 4, I can do Toyota.loc 0 to 4. Similarly, you can do Toyota.head within the parenthesis as 4, and so on, like this. So these are all different ways to slice a data frame and get only specific rows in the corresponding setting. So the other thing is about Boolean filtering, like given a Boolean condition, let's say I want to retrieve the retrieve a part of the data frame such that the columns in that corresponding to the price is above, let's say, 20,000, let's say. So what I can do is as follows, like I do a first indexing of this. So the original data frame Toyota I have. Within that, I add the condition where the columns price, all the entries where under the column price is above 20,000. So I only retrieve those items. Similarly, let's say my fuel type was, I want to only retrieve for diesel fuel type, then I can just do a simple Toyota fuel type is equal to diesel. And so I can also do it via LOC also, .loc, where my KM column is less than equal to 30,000, but at the same time, I also want to retrieve price and age corresponding to those columns. So all those things can be possible using this Boolean filtering aspects that we also saw in the other. setups. Okay, I think those are like the some of the functionalities. There are many advanced sort of Boolean filtering you can also do. So I would highly suggest again to go to the pandas documentation. They have a very good documentation available online. So for anyone interested, you should highly suggest that you should go through them also. So you can also have multiple filtering or multiple Boolean filtering conditions, like just not one condition. On so let's say I want to uh, get all the card information where the age of the card is less than 36 and the fuel type for that card is also equal to diesel. So then I can just add these two Boolean operators like this and add a AND operation, which gives me age less than 36 as well as the fuel type equal to diesel. You can also have something like odd operator, like similar to how Boolean odd operators operate. So all these things are possible, which are also there in NP, NumPy array and all. So it's very similar to that only. So you can also sort values in the settings. So before we go ahead, like I think if there are any specific questions, I can take in. So you can post in your questions, let's say for 2-3 minutes, and I think I can take up those first, and then I can go forward with the because there would be some complexity involved in the data frames functionalities. So if you have any doubts here, I think let's first clear those and then move ahead. So we'll take some questions for 2-3 minutes, and then we'll move ahead. We'll take in the questions now. I think then move ahead with the rest of the talk. Um, So I think is this possible on Google Colab? Yeah, so everything is possible on Google Colab. You can just import the library pandas there itself, and you just can copy paste the code as we are showing here. And all these things we can do. So what's the use of iLock? So iLock is similar to lock itself, but it's more about the index of the location. So you can give the row ID actually. So in the row index there. So in lock you just give the corresponding row number, let's say. So that's all. So the other question is we have import OS. So I think OS library you can also import corresponding to, let's say, reading files and all. You for pandas specifically you don't require OS library all the time. Um, First, third, second, and third week sessions PPT. So I have uploaded I think in our internal the Google things in the Google Drive settings. I think we should be able to access it. So please speak to your NPTEL coordinator for it. Um, so card dataset CSV. So you can search for card dataset CSV online. Toyota Corolla card dataset. It's part of the syllabus. You can just search online. You'll be able to find the link. Um, yeah. So even I think Panda CSV has Pandas actually has the dataset car CSV itself, I think. Hello, I think I had lost the internet for a minute, so I hope you're able to hear me. So I think there was some network issue at my end. I hope you are able to hear now. Okay, so I think the question I was discussing was about where to get the card dataset CSV. So you can find it online. So you can search for Toyota Corolla dataset. You should get the CSV file online. So yeah, so I think those are mostly the questions. NPTEL admit card, I think you should talk to the NPTEL coordinator about. So you should get that there. So why in the very first slide SNS or set theme was used? So okay, so for pandas pre-processing, you don't need SNS or set theme. Just because we would be doing the seaborn plotting later on. So we use the SNS dot set theme at the start itself. We'll look at once we get into the C1 slides. Then we'll get that. Um, any other questions? If we can have quiz at the last, we'll try to see. I think we'll have some kind of coding exercise. So we'll try to see if we can do it at the end, based on the time limits and all. Okay. So we'll go ahead now with the rest of the session. Um, So we were discussing about the sort values on pandas data frame. So given, let's say, this data frame, we want to sort by corresponding column feature, let's say. So given the price is featured in the data frame, I want to get the top K, let's say top five cars with the top five price. So I can just do five most expensive cars as Toyota dot in largest, add the parameter 5 here and the column name price. So it would give me the list of cars which are at the top 5 expensive list. The other thing you can also do is that you can do youngest first, like you can do multiple sorting at the same time. So you can first do, let's say, by age, you can sort the car, and then within that, you can also do cheapest. So you can do something like dot or sort values by the corresponding column names, age and price. For age, you would have true, so it would go on from young to old kind of thing, ascending true. And for price, it would be cheap to expensive. So this should give you a sub data frame out of it, and you can just do dot head also to get the first 5 rows of it. And you can also do restore a simple this thing to 0 to n-1 index. So for example, you are already have sorted this thing, but you want to go back to the original settings, so you can just do reset index also. Um, so you can create new columns, you can rename new columns and even drop columns in the pandas data frame setting. So okay, there is a question in the chat. Where do we find coordinator and mail ID? So I'm also not sure. I think in the website of the course you would find the coordinator ID, or you can email NPTEL from the course itself. There should be a email ID there. You can email there and to ask these questions. So create, rename, and drop columns explicitly. So for example, if you want to create a new column, you can add, let's say, Toyota age years. Age years is a new column. So what I'm doing is I'm converting to, let's say, in months. The age was in months. I want to convert it to year setting. So I can just divide by 12. So I'm doing Toyota age divided by 12. I'm creating a new column, age years, and that's my new column here. I can also rename a particular column. Let's say the km column, which was there, I want to rename into kilometers. CC, I want to rename into engine CC. So what I can do is that I can do rename. Within that, I would add columns equal to, and then the corresponding column, the old column name and the new column name. I can also drop a particular column. That means I can actually delete a particular column from the data frame. So I can just do Toyota.drop columns equal to met color. So in my final data frame, the met color column won't be there anymore. So that's how to drop a particular column. So as I mentioned, like you can you should use a dot copy here. So copy actually protects your original reference point. So if you don't want to make changes in the original settings, similar to how in NumPy we saw, you should use dot copy. Those are like some of the settings that you should keep in mind. So the other thing is like now coming to something called about the visualization settings now. Value counts is basically my frequency values. So let's say Toyota fuel type is fuel. So fuel type was three categories in this dataset. One was petrol, diesel, and CNG. So when I do Toyota fuel type dot value counts, it gives me the for each category, like for petrol, diesel, and CNG, how many items or how many cars are associated with that fuel type. So it gives me this nice visualization here, like where I can see for petrol I have 1264, for fuel type diesel I have 155, and CNG I have 17 cars. I can also do this. I can also do a normalization of this value counts, and like convert it into percentage also. So like so for example, 1264 divided by 1463, like the percentage of cars which are petrol fuel type or percentage of cars which are diesel fuel type and all. So all this I can try out from this value count setting itself. So as we can see here, see from the plots here, the data set is very imbalanced. Like petrol actually dominates the data set. Like most of the cars are fuel type petrol, while CNG is very rare. And now so this gives me one kind of pattern, a visual or interpretable pattern, let's say in the data set that I can see from the thing, from the data set itself. So likewise, we would see multiple such patterns as we see multiple visualization aspects of data frame. So there is also this thing called group by. So let's say I want to group the data by particular column name. Let's say I want to group by the fuel type, price. So this is very similar to if people already know about SQL. SQL is a language for the programming. So anyone who has already been introduced to SQL programming should know about these things. Like you given this SQL tables, how you can do group by operations and all those things. So it's very similar to that itself. So you can group by and then you can aggregate via count, mean, and median settings. So it gives you the corresponding output on the right, but you are grouping by fuel type, and for each of them you are having the corresponding count, and for price you have the mean price of it and the median price of it. And so these are my kind of different aspects of things here. So there is also a thing called pivot table. So you can create a two-way summary of out of a data frame table. Let's say these are my corresponding values and the indexes that I provide, and I can create a corresponding pivot table where it shows for the corresponding fuel types. I have how many manuals and how many at automatics card. So my columns are my automatic and my indexing aspects is by fuel type. And here I'm just showing like the mean price of it. So you can have the aggregate function as mean, where you can apply this mean price for manual type cars, which corresponds to petrol as a fuel type or diesel as a fuel type, and so on. So now we'll look at this kind of exploration aspects of this tables. So typically we want to look for relationships or relational table structures from this unstructured information in the table. So typically in a table there are lots of information, but many things are related to each other, like some of the columns are related to each other. So you'll see from the patterns in the dataset itself that there might be some relation across them. So if my mileage of the card is much more than the price, also follows a higher pattern for that car. So likewise, this relational structure might exist in the table. Quality like missing values, duplicates, and all those things we also have to check for those. Like one variable aspects like counts, center, spread, and shape of the data set. And two variables includes like correlation plots, where you have two features and how the data set like how the across these two features the patterns look like. So whether one feature or one column is correlated to with the other or not. So the different kind of things we would look at here. So the first thing is this thing called describe. So let's say I have the data frame where I only want the corresponding columns, price, age, kilometer, HP, and weight. For that, I want describe. I call this function dot describe. It gives me the following. It gives me the statistics aspects of across each of the columns. It gives me the mean statistic for price, age, kilometer, and so on, the standard deviation, the minimum value, the 50% threshold, the maximum, and so on. So summary statistics actually gives you some kind of aspects about, let's say, if your data set was imbalanced, those kind of information you can quickly get from .describe. And visualization actually shows you the distribution behind them. So this is just like simple point estimate values here, but you can actually from visualization you actually get the overall picture of the distribution, data distribution, and the underlying data distribution. So there might be some aspects of heavy tail distribution, let's say, or some tail distribution that you can observe, all those things. For example, if you now want to actually check if your data frame has any missing values or not, or any duplicates or not, before you do your analysis, you can do something like toyota.isna.sum. So that basically means that you only retrieve the if my values is a nan value or not, I only retrieve those nan values and then I calculate the sum of it. If my if there are some nine values, then the sum would be some non-zero thing. But if it gives you a zero, then it's means that there are no missing cells in the corresponding column. If you want to see if your rows are duplicated or not, so you can just do dot or duplicate it, and then you can calculate the number of duplicate rows using this. And you can also remove duplicates as well, with something like drop duplicates. If your data frame previously had duplicates, you can do drop duplicates to delete them. And so these are very like useful kind of functions. So you don't have to by hand manually pre-process any of these things. You can just simply make this function calls and it will do it for you. So now coming to the data set once again, and trying to you will now try to find out some kind of patterns in the data set. So one of the patterns is this, that what we are doing here is that we are trying to find some kind of correlation between the price and age. For example, here we have what we are doing is that we are trying to select the data types as number. That means all the columns with D type numerical, only those features we are considering. And for that, I want to correlate with the price. So what I'm doing is that we are first selecting all the columns which are numerical types, and then I'm adding dot core, which is basically means the correlation function with the corresponding column price. So price is my target column here, and then I can drop the column actually in my correlation plot, and then I just do a sort values of it. So I can sort the values in ascending order. So here on in a visualization setting, you can see like there is some corresponding correlation, like Pearson correlation with the price target. So weight has, let's say, 0.58, some kind of correlation and so on like this. So these are like kind of settings here. So now, so we kind of have this short quiz kind of thing. What you can do is that for I think if you already have the dataset open with you and you are already coding up side by side, I think you can answer this question. So I think I can take up 3-4 minutes here to sort of uh, so you can just work out this thing. So given the data set, how can you find this answer to the count and median price for each fuel type? So we can pause for 3-4 minutes here, and you can try this out at your end. So you can open Google Colab, you can download the data set and try it out. Okay, I think you're. I hope you are able to try this out. Okay. So I think some people have already posted the solutions. So let me go to the solution now. So if you're not able to try this out, you can try it out offline also. You can try these things out very quickly on Google Colab. Like just copy paste the same things there. So this is the thing. So you first create a subset of the data frame with the columns price, age, km, and fuel type. Then what you would do is that you first filter out fuel type equal to petrol, and then for all the correspondingly age less than 36 and kilometer less than 50,000. Once you do that, you get recent kind of you store it in a different framework called recent petrol, and then you can do a summary out of it with using group by for fuel type and price corresponding with count and median. So this gives you the corresponding summary out of it. So I think people have yeah, I think you can do it in multiple ways. You can use a pivot table also to do this, or you can do a summary group by also to do this. So any of these two settings are correct. So yeah, so now we want to look at the pre-setting, like the pre-plotting setup when before we try to plot the data set. What are the other things that are remaining for pre-processing aspects? So we always want to, as I also mentioned in previous slides, that we always want to clean or do good pre-processing on a copy of the data, not on the original data. So we use dot copy so that the raw data is reserved for comparison aspects. And you can also reduce accidental changes in the original data, and you can make the cleaning pipeline repeatable also. So you can use the same cleaning pipeline without actually changing the original data. So the other thing is that you should also convert the data types based on the meaning of the on the of the column name and all, not just based on the values in the data frame. So for example, fuel type, if it was you can convert it to as type category. Automatic, you can convert to as type boolean and so on. So you can also, if there is any messy kind of CSV files that you have, so you can use something called pd.numeric that can help you to like clean the file or clear out any such errors as such. So it is a more like robust numeric conversion that can help you. So any kind of invalid numeric text, let's say, using this thing called error scores would actually convert it into an AND value. So you can handle that much more better instead of having a long numerical text. So those are like different functionalities in for pre-processing correctly. So the other thing is that during missing value handling, it depends. You need to ask why the value was absent. So for example, um, of course you have to first diagnose and see like how many missing values are there. So for that, you can just do dot mean and dot sort kind of settings. Now, it might be like missingness is kind of rare or systematic in the data set. Um, it might be also that the zero, let's say you're thinking of it as a missing value, zero, it might be actually a valid value for it. So just without thinking, just converting that zero into a missing value is it might be problematic. So you have to also think about which values to convert to a NaN or not. Um, so also convert filling this with missing values actually should it distort the original distribution of the data? That is also one question that needs to be thought about. And lastly, whatever the model that you are training, let's say any machine learning model, you have to also consider the fact whether the machine learning model can accept the missing values. So otherwise, you will throw errors during the training process. So all those things needs to be carefully determined before handling for missing values. Yeah, so there are other things about outliers in the data set. Like, for example, you want to throw away certain outlier data points, let's say the price points that follow outside some 75 threshold quantile or 25 threshold quantile, you want to get rid of them. So you typically do it via something called interquantile thresholding. So you uh, get the first quantile Q1. So all the values that are greater than equal to 25% of the data set. And Q3 is basically all the values greater than less than equal to 75% of the data set. All the values that lie within it is basically my Q3 minus Q1. And I can do some quantile thresholding here. The remaining elements I can just drop it out, and you can keep the remaining ones. So you can also encode categories when your algorithm needs some kind of numbering system. So you can because typically machine learning algorithms don't actually take this kind of categorical features. You have to convert into some kind of one-hot encoding aspects. So you can convert those categories into those indicator variables. And you can also consider feature engineering that turns these raw columns into visual concepts. So, which we already had discussed. Let's say you want to create new features out of the dataset that was not previously there, because these are actually a good essence for a clear interpretation of the dataset. You can have useful information at the pre-process before the pre-plotting time itself. You can also have settings where you can avoid division by zero and so on. And you can also scale certain numeric features based on when particular method benefits. For example, if you want to do some kind of clustering algorithms on top of your data set, like k-means, k nearest neighbors, scaling actually helps. So you want to do some scaling across these values for age, kilometer, and all those things. For neural networks and all, you can also do the scalings. For plain plotting, you don't need scaling because you just need to visualize the thing and all, so you don't need typically scaling there. So now, there are different kinds of plots that we will look into, and many plots serve different functionalities. So, for example, the first one is called scatter plot. Like, you want to first investigate like how two numeric variables move together. So that's where scatter plot helps. For example, now if you want to see how does a value change across an ordered axis, let's say, then you can use something called line plot. If you want to check for categorical plots, like categorical features, like how these categories compare against each other, you should use a bar plot. If you want to check a variable's distribution, then histogram plays a role. If you want to see group distributions, comparisons across group distributions, then you should use something called box plot. And for pairwise relationships, you should look at pair plot. So all these things are different kind of visualization styles that we will look into. The first thing is called scatter plot. Scatter plots, for example, I want to check between two numeric values, price and edge. So what we are doing here is that this SNS, the C1 library that we have. So first I'm creating a plt.figure. It gives me a blank figure to be plotted of size 8 cross 5. And on the top of that, I'm adding SNS scatter plot, which is gives me the scatter plot functionality. I'm loading the data as Toyota data frame. The X axis is the age column. The Y axis is my price column. And I actually have something called this hue or color. Basically, that means that I'm categorizing the plot based on the fuel type. The coloring of the plots is based on the fuel type. And there are other aspects like alpha and S, which are basically parameters for the visualization aspects, like the size of the corresponding dots in the scattered plots and all those things. So these are just for visualization purpose. And you can add labels and label names and all those things also, like plt.x label and plt.y label. These aspects you can add in the data frame in the plots. Similarly, you can do plt.title to add a title to it, and you get this kind of plot on the right hand side. You can see that as your age increases of that card, your price drops. This is very typical and this is very a normal scenario. So there is something of a pattern that you can see from the dataset. So yeah, so the other thing is something called line plot. If you have something, let's say, um, um, just a moment, I think. Yeah, there's some. Yeah, so if you have something like a line plot setting, so line plot basically means that it connects the data points between any two points using a line. So this is the same price age thing. Only thing is that instead of the scatter dots, you now have a line connecting between each of the points. So up till this point, if there are any questions, I can take up, and then I think we only have around 15 minutes of the setup left. So I think we can take up some questions now, and then we'll move ahead with the other rest of the plotting steps. Um, so you can ask any questions in the meantime. I think questions. Age is continuous, then how we find age wise mean? So yeah, I think age is a floating numeric, so you can find age wise mean simply because it's a numeric value. So you can get the mean of it. Okay, I think we can move ahead then. So this was the line plot. The bar plot is basically looking at the distribution for each variable. So for petrol, I want to see the mean price of it. So it shows me for each fuel type corresponding mean price distribution. So this is my setup that we show see here. The second is that varying the price factor on the x-axis. If I want to plot it as a histogram, let's say, it gives me the number of cars corresponding to the price. So I can do sns.his. His plot gives me a histogram plot of where the x-axis is the price, y-axis is the number of cars. Y-axis I don't need to specify actually because I am getting a frequency kind of thing. So the whatever the column that I'm passing on is the frequency that I'm getting. I can specify the number of bins. So it gives me 20 bins and all, and colored and all those things. There's this flag called KD equal to 2, like kernel density estimation kind of things, which we won't look into much details here, but you can read through these patterns in the documentation also. So this is another thing called box plots, which gives you a variation of the distribution for each fuel type here. So you can do SNS.box plot, and you can specify x and y axis. Fuel type is my x axis, y axis is my price, and it gives you the box plot actually gives you like what is the minimum average and the maximum range of values that are lying here. So those things you can, and also the quantile images and all this you can get from the box plot distribution. The other thing is called pair plot. So in pair plot, what we look at is like any two features. Let's say I want to see correlation of this kind of things. So for on the right hand side, we are showing the corresponding setup. So you can just do SNS dot sorry, you can just do SNS dot pair plot corresponding data set columns that you want to show, and the bars equal to cols. That means all the columns that you want to compare one and one against. So pairwise you get a plot out of all pairwise column comparison, and those are like kind of the setup for pair plot. So it's usually used for correlation kind of plotting where you want to see whether there exists any correlation across different plots or not. So moving ahead. So the idea is that why do we what are the essentials for a good plot? Good plot should always have a good title, access labels, tables, a readable scale, a legend only when it's needed, sufficient contrast and marker size. You should always have a 3D effects in the plot, unexplained colors, tiny labels, truncated accesses that can be misleading, too many categories. And at the end of each plotting code, you should always add the plot title, plot X label, plot Y label, plot the legend, plot type layout, and plot plt.show. Plt.show is essential because it gives you the rendering out, the output gets rendered in your screen. So these are the kind of things that you should keep in mind. So the other question, the last question for today is this. You can try it out at your end. So you should try to make two plots that answer these questions, like a scatter plot of Km versus price, which is colored by fuel type, box plot of price across three fuel type groups. And for each plot, you can write one observation, like if you see any pattern or something. So we'll take like 4 or 5 minutes here. Just try to work it out at your end. Like you have Google Colab or Jupyter Notebook or VS Code or Spider, any of the coding IDs, you can try it out. So we can pause here and try out this quiz. Yeah. I think since we are short on time, we will be moving ahead to now. Um, I hope you are able to create this setting. If you're not, I will show you the solution. But you should try these things out at your end as well about this event plotting styles. You can also read through the documentation on Seaborn and available online to get understanding around it. So this is like the solution here. We first do a scatter plot with fuel type as the color, x-axis as km prices column, y-axis. And then you set the titles as axis is zero dot set title and all. You also set the so this is about the scatter plot. You can also create so what we are initially doing is that we are creating two subplots. So that's why we are having access uh, we can access equal to equal to a subplot. Uh, and so there are two subplots. So I'm specifying that as 1 comma 2. So access there are two accesses. So one is for the scatter plot, one is for the box plot. So for axis is 0, you are setting the title as follows. And for axis is 1 for the box plot, you are also setting the title X labels and Y labels. So this is what you are looking at. Um, so I think most of the settings are kind of like becoming about the last part of this session is about the execution for automating decisions. So if I, let's say, uh, I want to, based on the data frame itself, I want to take decisions specifically. For example, if my median price of a car is greater than 10,000, I want to take some action there. So this is if else condition that you can create here. Like if this thing happens, then you can print this thing and all. So if executes a block only when a condition is true, you can also do if else kind of settings where you have multiple conditions at the same time. So you have if, else if, and lastly as the last condition as else. You can also have the for loop thing, which basically looks at so here what we're doing is that given this columns, list of items in the columns, and iterating through all the columns here. And for each column, I'm taking the average of it and then printing it. So that's like a for loop that we are looking at. Similarly, you can apply loop at other settings also in different actions. Like within a for loop, you can have if else condition also. So all these things are there in these things. You can also use the break condition. So if you want to break out of a loop, let's say the for loop here goes through this sorted cars iter rows. Basically, that means that through after sorting all like you're iterating through all the rows. Whenever your car kilometer is less than or equal to 10,000, you are printing those. But if it goes beyond that, you are breaking out of the for loop. So you don't have to actually look through the entire data frame. You only check until your car kilometer is hits 10,000 or not, or is greater than 10,000 or not. So this is again like while condition. While is another kind of equals function block where we can look at whether uh, uh, you have some kind of initial state and you have a condition. If until you fulfill that condition, you go on, and if you already fulfill the condition, you then stop. So these are like different aspects of the settings. And I think since we are on time now, so I think we'll be closing soon. So I hope this gives you a broad overview of today's topic around Pandas data frame and different functionalities around it, like plotting aspects and all those setups. So next week, I think we will look at a recap of Pandas data frame once more and do a small case study on regression and classification. So next week, I think probably is the last week, I guess. So we'll look at those things and some portions of functions are remaining. So we'll cover that in next week itself. So once again, thank you for joining for today's discussion. We'll hope to see you again next time at same time next week on Saturday, 3 to 5. Thanks again for joining for today, and we'll hope to meet you again next week. So, so we also have the slides available online, as well as the lectures should be uploaded on YouTube soon. Today's lecture will be uploaded on YouTube soon, so we'll share those ones. Those are done. So recorded video is only one recorded video. So both the recorded videos are there. So you can see on the Excel sheet, it's uploaded already. So thank you once again for joining today, and we hope to see you again next week. Thank you. I'll end the call here.